Imagine a dirty snowball from another star slipping through our solar system, warming in our sunlight, and then leaving forever. That actually happened. We named it 3I Atlas, and while it was here, the James Webb Space Telescope found methane and a chemical mixture unlike almost every comet we know. Radio astronomers also pointed dozens of antennas at it and asked the question everyone was thinking, is this thing transmitting? But the most revealing moment came because part of an observation failed. Keep that in mind, because by the end, that little mistake will tell us what was hiding beneath the comet's skin, and what we nearly missed as it passed. iAtlas was reported on July 1, 2025, after an Atlas survey telescope in Rio Hurtado, Chile, spotted a faint moving speck. Atlas is basically a robotic night watchman, repeatedly photographing the sky and checking whether any dot has changed position. Astronomers reconstructed this dot's path and realized it was moving far too fast for the sun to keep. Picture rolling a ball up a hill. A slow ball comes back. A sufficiently fast one crosses the top and never returns. This comet was already over the top. Its route was an open curve, not a loop, proving it had entered from interstellar space. That explains the name. 3I means the third confirmed interstellar object, after Oumuamua in 2017, and Comet Borisov in 2019. Atlas is the survey that found it. At discovery, it was traveling about 221,000 kilometers per hour. Solar gravity accelerated it to roughly 246,000 kilometers per hour near its closest point to the Sun on October 29 or 30, 2025, depending on the timing convention used. It passed about 1.4 times Earth's distance from the Sun, just inside Mars's orbit, while Earth was inconveniently on the far side of the Sun. It never threatened us. Its closest approach to Earth on December 19th was about 270 million kilometers away, nearly twice our distance from the Sun. Even its solid nucleus remains poorly measured. Hubble constrained it to somewhere between roughly 440 meters and 5.6 kilometers wide, because the surrounding dust cloud blurred the central body. What mattered was the fuzz around it. Some light heated its ice, which changed directly into gas, like a shrinking ice cube skipping the puddle stage. That gas carried dust outward and formed a glowing envelope called a coma. A coma is useful because a distant comet is otherwise like a sealed freezer flying past at highway speed. Heat opened the lid and telescopes could inspect what escaped. Webb first examined 3I Atlas before its closest solar passage and found a coma extraordinarily rich in carbon dioxide compared with water. The measured carbon dioxide to water molecular ratio was about 7.6 to 1. That is far outside the usual range for comets near the Sun, although unusual solar system examples do exist, so it was not proof of anything artificial. Then Webb looked again after the comet rounded the Sun. On December 15 and 16, its mid-infrared instrument, essentially a chemical barcode reader for invisible heat light, split the comet's glow into wavelengths. Molecules absorb and emit at particular wavelengths, leaving recognizable stripes, like supermarket products carrying different barcodes. Those stripes revealed water vapor, carbon dioxide, atomic nickel, and for the first time directly on any interstellar object, methane. Methane sounds dramatic because living organisms on Earth make plenty of it. But methane is not automatically a sign of life. It forms through ordinary chemistry and is common in cold space. Calling its detection evidence of aliens would be like finding smoke and insisting it came from a dragon when a campfire is sitting beside it. The genuinely strange part was where the gases appeared and how their amounts changed. Water spread far beyond the nucleus because sunlight was vaporizing tiny grains of water ice carried into the coma. Methane and carbon dioxide stayed concentrated closer to the solid body. Relative to water, both were unusually abundant. That suggests the methane had not simply been boiling away from the surface throughout the comet's approach. Methane is more eager to turn into gas than water is. If it had been sitting exposed in the comet's outermost layers, much of it should have escaped earlier. Its delayed appearance instead points to methane ice, buried deeper down, protected beneath an outer shell until heat from the sun slowly conducted inward, like warmth creeping toward the frozen center of food in an oven. There is an even more extraordinary clue in Webb's near-infrared data. Although the methane isotope analysis was still a preprint as of July 16, 2026. Researchers reported that about 3.31% of the hydrogen signature in the methane was deuterium, a heavier version of hydrogen containing an extra neutron. Think of ordinary and heavy hydrogen as identical tennis balls, except one has a coin hidden inside. That methane deuterium to hydrogen ratio was about 14 times the value measured in Comet 67P by the Rosetta spacecraft, previously the only comet with detected deuterated methane. Separate, peer-reviewed measurements also found exceptionally deuterium-rich water in 3I Atlas. The simplest natural reading is that this material formed in a much colder chemical environment than ours, perhaps in the remote outskirts of another star's planet-forming disk, and partly from even older interstellar cloud material. New results published in July 2026 added unusual carbon and nitrogen isotope ratios, strengthening the case that this comet may preserve material from an old, chemically different stellar environment. Precisely how old it is, and which star expelled it, are not known. Its arrival direction does not give us a return address after immense stretches of galactic travel scrambled the trail. And yes, scientists listened for technology. Within a day of the comet's announcement, the SETI Institute used the Allen Telescope Array in California, a field of radio dishes working like one enormous ear. Across more than 7 hours of July observations, the team searched frequencies from 1 to 9 GHz from narrow radio tones. Natural sources usually spread their energy across a messy range. A tone squeezed into a tiny frequency slot is more like a whistle than ocean surf, and can indicate a transmitter. The computers initially registered nearly 74 million narrowband hits. That sounds spectacular until you remember that Earth is deafening. Satellites, aircraft systems, and ground transmitters leak radio energy everywhere. Filters reduce those millions to roughly 200 signals whose frequency changes could resemble the comet's motion. Researchers inspected them. Every one traced back to human technology on Earth or in Earth orbit. Within the frequencies and signal types examined, they could exclude a transmitter near 3I Atlas radiating more than roughly 10 to 110 watts, about the power draw of an ordinary household appliance. Breakthrough Listen later searched with the Green Bank telescope across 1 to 12 GHz and likewise reported no candidate technosignature. That does not prove the comet carried no technology imaginable. A transmitter could have been silent, intermittent, aimed elsewhere, outside those frequencies, or using a signal the searches were not designed to recognize. Radio silence is evidence against a particular kind of broadcasting device, not a universal certificate declaring no aliens. More importantly, the comet's visible coma, ordinary heat-driven outgassing, and small expected trajectory changes all fit a natural comet. Claims that it was an engineered craft never gained supporting evidence. Now, remember the failed observation.